Hello everyone. So in our last lesson we talked about what are the parts of a parabola. So let's take just a moment and review those. So we're going to do a quick sketch. And let's label it like this. And let's talk about these as we graph them. Let's say we have a point here. That would be a 0 or an x-intercept. If I had a part here or a point here, that would be considered the y-intercept. I'm going to put another 0 over here. And let's say we have, oh, I'm sorry. Let me go over one more or two more. There we go. And then I'm going to put the vertex right here. So let's sketch this parabola. Okay. So again, I have x-intercepts at -2, 0 and at 4, 0. I have a y-intercept at 1, 2, 3, 4, 0, 4. And then my vertex is at 1, 5. But now let's talk about how to use these to answer questions. So these questions, by the way, are called projectile motion questions. In other words, the way something you throw moves. That's why we call what we're doing today projectile motion problems. So here we go. Let's say I throw a ball. Your -0 cannot be used in this situation. So that is not of any help, it's no use, it's not a solution. So that's not going to help us. Now let's look at the y-intercept. Our y-intercept here is at 0, 1, 2, 3, 4. So our y-intercept is what's called our initial height. And that makes sense because in every single function that we've talked about, your y-intercept is your starting amount, or in this case, your starting height. And by height, your y-axis represents, your distance, and your x-axis represents your time, distance over time. All right, so let's say, let's keep labeling. The next point that we encounter is the vertex. Our vertex in this problem, remember, it's in the point or the form xy. Every point is xy. Well, the x is when your object reaches its maximum height. And your y, think about it, if distance is on your y-axis, your y value in your vertex is what is your maximum height. So the what of the maximum height, and I'll show you how to use this in just a moment. And now let's go back to the other 0. The other 0 in this case is 1, 2, 3, 4, 0. So the excuse me, the positive 0 is how long it takes for the object to hit the ground. So your positive x-intercept how long it takes your object to hit the ground. And there's another thing you can do, and I'm going to talk you through another specific example, but if it asks, there's one more question, how high the object is at x seconds, you plug that value, plug x into the equation. And again, we're going to do a specific example, but first I wanted to label the parabola. So let's talk about this specific object. Let's say you're throwing a baseball. So all of these dots, I want you to pretend they're a baseball. So let's talk about the y-intercept. This baseball is 4 feet off the ground when you throw it. So my y-intercept is 4, so this baseball was thrown from a height of 4 feet off the ground. Now let's go over to our vertex. The actual vertex here is 1, 5, 1, 5. So that tells me it reaches a maximum height of 5 feet off the ground when I throw it. How long does it take to get there? Usually time is in seconds. So 1 second or 1 minute or 1 hour, whatever it tells you your time is measured in. So that's how you use the vertex. Now let's go down to this positive x-intercept. The x-intercept here is 4, 0. So again, let's use seconds for time. So that tells me how long does it take to hit the ground? It takes 4 seconds for this ball to hit the ground. So now let's take this and apply it in a way that you'll see on your problems today. So I want you to pause the video and copy the problem. So now that you've copied this, it says Zen throws a ball upward with an initial upward velocity of 54 feet per second. The ball is 5 feet above the ground when it leaves Zen's hand. Use this function to answer the questions below. Well, at this point, I'm going to tell you that 54 is extra information. So what I want to do, let's look at our questions. What is the initial height of the ball? What is the maximum height that the ball reaches? How long did it take the ball to reach its maximum height? How long did it take the ball to reach the ground? What is the height of the ball at 4 seconds? So that tells me I need to graph this equation so I can use our key points or our parts of the parabola to answer the question. So the first thing that we're going to do is we're going to go over to Desmos and type that equation in. So remember, anytime they have h of t, f of x, that just means y. So y equals, and anytime they have t, x, something like that, like h of t equals negative 16t squared, the t is x. That's your input or your x. So y equals negative 16x squared plus 64x plus 5. So now that I've got my graph, and I always like to double check, y equals negative 16x squared plus 64x plus 5. Yes, good. So now I want to answer my questions. So the first question says, what is the initial height? So if I look back, your initial height is your y-intercept. So I want to jot that down. Initial height is y-intercept. So let's go find our y-intercept of our graph. So I see our, there we go. Oh, there it is right there. It helped us find it. So our y-intercept is at 0, 5. So our y-intercept is 0, 5. Now let's use that to answer the question. So what is the initial height? Well, I noticed in our problem, they talk about feet and they talk about feet per second. So that tells me when I talk about height, distance, I'll talk about feet, and when I talk about time, I'll talk about seconds. So what's the initial height? The initial height is 5 feet off the ground. Now let's look at number 2. It says, what is the maximum height that the ball reaches? Well, when we talk about maximum height, we look at and you can look back at your graphic organizer, the maximum height is your y value of your vertex. So I'm going to say, let's write it this way, our y of our vertex. So let's go find our vertex on our graph. Let's see, we might have to, there we go, there's our top. So our vertex is 269. So what's the y value of that? 69. Okay, so 269 is the vertex, but our maximum height is 69, and remember we use feet. So the highest that that ball went was 69 feet. Now let's look at number 3. How long did it take to reach its maximum height? Well, if you look back at your graphic organizer, when for the maximum height is the x of the vertex? Well, didn't we just find the vertex to be at 269? So what's the x value of that vertex? It's 2. So it took 2, and remember we have feet and seconds, so it took 2 seconds for it to reach its maximum height. How long did it take the ball to reach the ground? How long to reach the ground? So if I look at my graphic organizer, and eventually guys, it kind of looks like the path of a ball. So you'll understand, you'll get the flow. But the positive x-intercept is how long it took to hit the ground. So our positive x-intercept. So let's look back at our graph. Let's go home. So our positive x-intercept is 4.0770. 4.0770. So our x-intercept is 4.077. How long? Talks about seconds. So it took about 4 seconds for the ball to reach the ground. Now let's take a look at number 5. What is the height of the ball at 4 seconds? This is the one where we're going to have to take the equation, or the function, h of t equals negative 16t squared plus 64t plus 5, and it wants us to find the height of the ball at 4 seconds. So we want to find h of 4. So this is going to be negative 16 times 4 squared plus 64 times 4 plus 5. Here's the beauty of using the calculator. I can go back over here, and everywhere I have an x, you know what I do? I simply replace it with a 4, with a times 4. Times 4 to the second power, 64 times 4, and look at that. Let me make sure I've plugged it in correctly. Yep. So, what will the height of the ball at 4 seconds be? 64 feet. So take your time, use your graphic organizer up here as you need to, and I'll talk to you guys later.